Okay guys, so next thing we're going to look at is dilations. So a dilation is a transformation that changes the size of a shape. Okay? So I like to think about when you go to the eye doctor and they dilate your eyes to check them, your pupils get bigger. They still stay the same shape, but the size of the pupil is what changes. Okay? So a dilation can enlarge an image, which means it'll make it bigger, or it will reduce the image, which makes it smaller. We have scale factors that are represented by the letter K. They control how much the image is enlarged or reduced by. Scale factors can be between 0 and 1, which means it will reduce the image. Or they can be greater than 1, which will enlarge the image. Dilations are the only transformations that are not rigid, meaning it's going to create similar images rather than congruent. Okay? So when we first started our geometry part in here, we talked about congruent transformations. So those translations, reflections, and rotations. Dilations are not rigid because the shape does not remain congruent. It is similar. But we still can have a rule for this transformation. We're going to use the letter D to symbolize the dilation, and it's going to be written in the form D and then a subscript K. That K is going to be our scale factor. And then to figure out the image from the pre-image, we will multiply by the scale factor with the coordinates. So D subscript 3 means that you dilate the image by a scale factor of 3. This would enlarge the image to be 3 times as big. So let's try example 1. So we're going to dilate the image using the rule D2. State whether this is a reduction or enlargement, and what are the coordinates of the final image. Okay, so D2 means our scale factor is 2, which means we're going to enlarge our triangle. So it will be an enlargement. Okay. I would go ahead and write out A, B, and C. So A is at 1, 0, B is at 3, 3, and C is at 3, 1. Then, to apply the dilation, we're going to multiply each value in the coordinate by 2. So that means A prime, we're going to do 1 times 2 to get 2, 0 times 2 to get 0. For B prime, we're going to multiply 3 by 2 to get 6, 3 by 2 to get 6. And then C prime, 3 times our scale factor 2 to get 6, 1 times our scale factor 2 to get 2. We can then graph this. So A prime is now at 2, 0. B prime is at 6, 6. And C prime is at 6, 2. So we have the same shape, but now it is larger than the original. So we can try example 2. Dilate the image by using the rule D1/3. Okay. State whether this is a reduction or enlargement, and what are the coordinates of the final image. So because our scale factor is 1/3, that means we're going to be reducing our image. So it should be smaller than our original or our pre-image. Again, I would go through the same steps. So A is at -3, 0. B is at 0, 6. And C is at 6, 3. Right? Yep. Okay. Then we're going to multiply each coordinate by our scale factor. So A prime is going to become -1, 0 when we multiply both coordinates by 1/3. B prime is going to become 0, 2. And and C prime is going to become 2, 1. We can then plot these points to see our transformed final image. So A prime is at -1, B prime is at 0, 2, and C prime is at 2, 1. So we still have our same triangle, but now it is 1/3 the size of the original. In example 3, we are looking to see what the dilation is, okay, or the scale factor for the dilation. So we can look from A to A prime. A starts at 0, 3, and A prime goes to, 0, 2, my bad, y'all, to 0, 2, and A prime goes to 0, 1. B starts at -4, 0, and B prime ends up at -2, 0. So looking at these two, I see that we're cutting the size in half or dividing by 2. So that means our scale factor is going to be 1/2. You can continue on and see the pattern that C starts at 6, 0, and C prime ends at 3, 0. So again, that dividing by 2 or multiplying by 1/2, and the same with D to D prime. We have -4, 0, and D prime ends up at, 0, -4, and D prime ends up at 0, -2. So each time we are cutting a value in half, all of the values in half, to see that we end up with a K or scale factor of 1/2. And our final example before you guys get to practice some of this on your own, determine which of the following figures could be a dilation of the triangle to the right. So looking at this triangle, which of the following can be a dilation? So I would first look for the one, so I'm like, okay, this one, we have that it goes from, we can use our proportional reasoning. So the first one, we can do 2.25 over 6. Does this equal our ratio of 6 over 16? Okay. The proportions are equal, so this one is similar. We can do this with the next one as well. 6 over 10, does this equal 16 over 20? It does not, so that one is not similar, and so it is not a dilation of the triangle. The third one we can go through, we can do let's do ours. 3 over 6 is equal to 8 over 16. Yes, that works, so this one will be similar by a dilation. And then our last one we have 5 over 6. Does this equal 16 over 30? It does not. So only 2 of our triangles in this example are dilations of our original. The other 2 are not proportional. Okay, our proportions are not equal, so they are not similar. So now guys, you are gonna work on this assignment. You can do your work on your own paper. You're gonna go through and practice each of these to find the missing length, solving the proportion, solving for a value, okay? And then working on dilations.